All right, should be broadcasting live and such. So this is a replacement. All right, should be broadcasting for the cnps or whatever it is, John Chappell Natural Philosophy Society. 10 a.m. usually Saturday morning, Eastern Standard Time anyway. uh, Physics chat room thing. So, because they aren't having one, I will try to do replacements when they don't do one. And so, people who may have been interested in seeing the other room may be interested in participating in this one. So, if you would like to participate in some other way than the chat, um, I will can provide you the link if you want to provide your email address in the chat. Uh, and might as well do it this way because we're going to have to eventually, because YouTube's getting rid of the PM system. So anyway, so you post your email and I'll send you the link, and hopefully you're not just being a jerk and looking to ruin the room, to suppress our free speech and all that. What am I looking for? Oh yeah, the chat. Got to pop it out and such. There. Ah, surprise, surprise, nothing there. That never happens. Anyway, so we can get rid of this and drawing if necessary. Yeah, okay, and such. So what we got here? Ah, yes, I just watched a video by Rational Science, Bill Gates, and apparently he's got a new book called "Why God Doesn't Exist." Yes, about. Well, you could write a book on that subject. There's just so many reasons. It's a silly story. The God who won't let you know what causes leprosy. You know, figure it out for yourself. Yeah, I invented it. I imposed it. Figure it out for yourself. I'm not going to cure anything for you. Common colds and flus and all. No, no, no. It's all your job. You figure it out. Yeah, right. Why God is an asshole would also make a funny book because clearly he's an asshole. The poor will be with you always, like the lepers, because I'm not going to give you any cures. Fuck. We had to fix most of this stuff, right? And some of it we're still blighted by. The cancer will be with you always. Fuck God. Fuck you. You know, give God cancer, asshole. So anyway, not really on the subject though. There's some crap in here. Why are planets round? And I've sort of discussed that, and that's sort of it. It just seems sort of obvious why big things are round. It's because the amount of pressure of all their matter is creating a huge amount of pressure in the middle and melting the middle essentially. So they all probably have molten centers, and every time they get pulled by gravity, parts of them are getting tugged and pulled, causing friction internally. Lots of reason for them to be hot inside, and clearly, once you do that, everything becomes a little bit mushy. So everything goes round, just the way gravity works. You can feel the gravity wants to make you round. It wants to incorporate you into the roundness of the earth. That's what it's. That's what you're feeling, is the effort to smash you into joining the balance of the gravity, as the gravity balances. So that's just kind of an easy answer, in my opinion. And the only reason why certain things don't go round is merely because they were never hot enough, to be able to be reformed. So they're in a shape that, you know, it has an uneven gravity to it, just because the gravity is not strong enough to knock that unevenness out. So anything big is going to be round. How big, what the line is between when you have to go round. Maybe it's, you know, 200 miles. Who knows? I don't know what this. I don't know what the biggest crooked or funny shaped asteroid is. I don't. But yes, it's going to tend to go round if the more massive it gets. And by mass, that means it has to have some heavy elements. But anyway, it's sort of not a complicated question. So this is a video just about, some speculation that planets are dead suns, which, I don't think works very well. But clearly, I think the stuff in this solar system could be stuff that's been in this solar system for a while, in the sense that our sun was once a different sun. It was once a big, big sun, and it blew up. And we're the remnants that got pushed out away from it and then have been drifting back, over time, let's say. I don't know about drifting. See, the catch is it's hard to catch stuff in an orbit. So to collect stuff gravitationally, you have to have collisions. So there's probably a way to say that. Uh, you must have collisions for a collection, some kind of, more phrasey, quotable kind of statement. Because the way gravity works, essentially, whatever pulls you in, whatever velocity you have to come into contact with something else, it will either not be sufficient to bend you enough and you won't get captured, or you'll spiral into the center, or you'll just hit the center dead. So you can't go from the outside and fall into a perfect orbit and just end up orbiting. That can't happen. Something has to slow you down, because you'll gain too much speed coming in to stay in the orbit. The gravity that brought you there will give you too much acceleration for you to stay in an orbit. So you'll just never be able to fall into an orbit. So you actually have to collide with something that slows you down, and now you can stay in the orbit. So it's kind of a complex process being captured in an orbit. It's not a simple thing that just happens. It's actually a byproduct thing that only happens after a bunch of other stuff happens. So part of the theme, if I have a theme, is the difference between the elemental physics, the function, like having a conversation about how the universe functions, because some of that comes up in this video where I don't know why I'm half off the screen. That's probably not a very good technical thing. Anything I didn't show. Anyway, so and having conversations about what happens over time with process. And I'm not terribly interested in origins and destinies of the universe. I'm not even terribly interested in whether the universe has a mechanism where the stars are essentially recycled. That is, they go through these levels of size, explode, start over, blah blah blah. They just cycle through a mechanism. And the galaxies are doing the same thing. That everything just going through a process of aging, and then fertilization and back into aging, and just a repetitive cycle. And the universe, in my opinion, could be that, or it could be the other way. It could be some sort of event that changed everything, and we're just part of that process of that change cycling out, and it will eventually just all dissipate and heat loss, and it'll all just turn into frozen bits. Yeah. Little bits. It'll all disintegrate into little bits. Back into little bits, very, very far up from each other, because they've been moving all this time. So, but I don't care one way or the other. So the more important conversation is about what the real processes are. So in this video, he brought up the solar wind as if it has a significant player in actually pushing planets or moons and all that stuff. And I don't think it can be understood to have any significant influence, because then Newton would have noticed that his math was off, because he didn't account for the photons hitting the planet and moving it, and the solar wind or whatever, all these little bits. So it's obviously not a significant pressure. pushing out, or it would have been recognized as the inverse square law doesn't work. That somehow the force isn't the gravity force isn't the major player, that somehow there's some other player that's compensating for it. And I suppose that number could be a byproduct of the gravitational constant, the big G, because that's basically establishing the units. But it still wouldn't account for the proportional differences in the fact that Newton's math worked just as good for things close to the sun as it did for things far away, except when it came to Mercury. But otherwise it was pretty good. Yeah. So it can't be a significant player, is all I'm saying. It's mostly what I'm saying. And let's see what else to start with. So to me, the more important physics conversation is about the basic function, and the stuff about how the function plays out over billions of years, to me, isn't as interesting a conversation. I mean, it's not what I would consider. I mean, those are fun physics conversations. Those aren't fundamental physics conversations. And it's clearly more important to even understand the process, what happens over time, conversations. If you have any of the elemental bits fundamentally wrong, then you're not going to be able to do the over time processing stuff. So you're not going to understand mechanisms at all. It's not going to work. Yeah. So I don't know if that gets into you can start talking. See, that's when spin comes into it, because we see spin in the big universe. Things are spinning, but the spin really doesn't have too much of an effect on too many things, except it seems like an obvious somehow spin is doing something in galaxies. Their spin seems more obvious to their function. And whether they're consuming matter or whether they're expelling matter, which is a question I think that's open. Some of this stuff, this is the problem with physics. Physics is really deep in terms of the amount of information there is, and it's all kind of, it's not real like obvious dinosaur head, bones. It's not like you're digging up something and you can see it. There's the eye sockets and there's the nostrils and the teeth, and it's not making it obvious. You have to take the little pieces, and put them together to try to piece it all together. So it's a little more work. And it's very difficult to be fully knowledgeable on all of these branches of physics. So I mean, I can't say I am aware of all the evidence that might support the theory that the galaxies are collapsing versus the evidence that the galaxy is expanding. Who's got time to do all that research? But by the math, you'd say their math has a problem and the things that are on the outside are going too fast, which is an indication that too fast also means they can't be staying where they're supposed to stay gravitationally, that they have the wrong number. Their speed isn't consistent with their orbit being maintainable. Is it probably a way of saying that? I believe it's a way of saying it. Yeah, that's close enough to a way of saying it. All right, so let's see if I can find the comment section. Yeah, that looks like it. Yeah, no chat at all. So, well, nothing I can do about that. Can't force people to show up and give a shit. But it doesn't matter. We'll just endeavor to persevere. Where's the actual Google thing? Okay, go here, and I can 7 viewers. Yeah, it's pretty bad. But it is, early in the morning in California, and 7 a.m. or something. So that's the downside. And this is the first effort at doing this replacement thing. And, but it's probably a good time in Europe now, right? Right in the middle of the day. Yeah. So we'll see. All right. So what else can I? So I don't, like I said, I tend to say conversations about how the universe are evolving. I don't know, not terribly interesting. More interesting is understanding what's the forces involved and where do they originate with. So like the conversation about why planets are round and why anything goes round. It's understanding the elemental nature of gravity itself, which is that it's a nuclear force essentially. It's affecting each individual atom. The atoms aren't being affected by gravity as a collective, they're being affected by gravity as individuals in one sense or another, either because of the pressure being created by the other atoms, they're feeling the gravity one way or the other personally. Okay, as either pressure, like the stuff under my feet is feeling the gravity indirectly through my feet pushing it. Um, Even if I absorbed, technically, the gravity, they still know it's there because I'm pushing them down and they're getting the message gravity is affecting me. And it's kind of like the air pushing on us, sort of. But yes, air, it's not a straight line force where gravity is a straight line force. So that's where the catch comes in, and that gravity can be converted into movement in some sideways directions. And that's part of what creates all the heat and everything else is the sideways pressure. So my feet push down, the ground might expand horizontally to account for my pressure because there's too much pressure lower and there's less pressure going sideways. So it just moves the crap sideways. So my foot can hit the ground and the ground will react by going sideways. And when it goes sideways, it creates more pressure on the other stuff that might go back this way. So that it might actually push something else up. My pushing down will push something else up. Um, Ironically. Yeah, so it's all about this pressure thing and the fact that it's manifested through these individual bits of stuff that have a force between them that doesn't allow them to fully contact each other. They don't bang in, electrons don't bang into each other, they bounce off each other's force, the radiation, like, like they were emitting air, shooting air out, and they end up pushing each other off their cushion of air. I don't know if that's a very good analogy. It's probably better ones. A radiation, says it. And for my brain, that's all you need to say. It radiates something, and the something is the radiation is what's causing something to say, I'm not going there. There's radiation coming off of it. It bounces off the radiation. So everything's in that condition in the universe. All the atoms are radiating pressure stuff. And so everything has this pushing away force created by the electrons that are always on the surface of things, the atoms anyway. So the atoms are more, they're going to tend to always be hostile to being too close because the electrons are going to repel each other. They're the membrane. So in a sense, atoms are a little bit like electrons because they all have a shell of electrons. And so to combine them, you have to find a hole in that shell, a place where there isn't an electron. And then the electron on the surface of some other atom can fall into that hole and now connect the two atoms because now they're the one has fixed its membranes. Now its membrane is complete, and the other thing that had the sticking out electron, it's a little bit like sex, I suppose. Something with something extra goes into something with something missing, and that combines the atoms. But their nature is to sort of bounce off of each other because their nature is essentially negative charge. And at close. So up close, they're negative. See, but that's a trick with charge, right? Which, is a known fact, is that you can have a net charge. So you have a 3 positive and it's got only a 1 negative next to it. And they're existing, like the Earth and the Moon. So let's say the Moon was a -1 and the Earth was a +3. Now, from a distance, that looks like a +2, right? So if you're in line with that from a distance, it just looks like a +2. So the Earth wins. But as you get closer, this 1 gets stronger and stronger by the inverse square law. And so eventually, when you get close enough, this 1 is the player. And this +3 over here is irrelevant because the 1 becomes the dominant controlling feature because of the inverse square law. Because this one's still further away, it's weaker. Even though it's stronger, it's still weaker. So, I mean, you could sort of argue that's sort of like, say, gravity makes a bad analogy because it doesn't have any plus and minus part to it. But you can sort of say that the surface of the Earth, I'm feeling a lot of gravity, but I'm not feeling any from the sun. The sun is 0.0000 meters per second gravity that it's affecting me by. So the sun has a tiny influence on me in the sense of moving me towards the sun. I mean, it's a tiny effect of my total gravity. And the dominant player is the Earth because I'm right on the surface of the Earth. So by the inverse square law, there's a strong pull towards the Earth. It'd be interesting, I guess, to calculate the number where when you travel from the Earth towards the sun, where you get to 0, where the pull of the Earth is equal to the pull of the sun. I would imagine the place is very close to the Earth. So if you drew a sun and you drew an Earth, that place is probably going to just be a little, by the size of the Earth. Maybe it isn't even going to be it'd have to be more than a few diameters of the Earth. But I mean, those are tiny diameters compared to the size of the sun. The sun's 1,000,000 times more big than the Earth. And the distance is incredibly far, 8 minutes by the speed of light. So it's a long trip. So yes, if you drew it, you probably wouldn't be able to see the point because it would be so close to the Earth that you couldn't even draw the point on the piece of paper. Probably. Yeah. Morning world. Okay, well, I suppose that's okay. We're doing a more civilized room, so I have to be moderator. So I have to be a nice person, mostly. Pretend to be a nicer person. So, good morning. What are you thinking about today? What's happening in your physics world? They're like Mr. Rogers. Yeah. You have a physics sweater? Hmm? Physics shoes? Hmm? You talk to the physics master in his little house in the other room? Hmm? Have any puppets? Puppets are fun, maybe. Not responding. But he might be handy capable or something. So it might take him a while to, participate. young ones are like that. They're a little intimidated. So let's see. Where was I? Gravity mostly and charge. Oh yeah. So it's an interesting fact that even though the atom overall from a distance might still be proton heavy in the sense that other free electrons would say, I'm going there because it looks like a, +2 and I'm at -1 and I'm going to be attracted. The closer it gets and it starts getting closer to the electrons, then it starts saying, oh, wait a minute, this ain't so cool after all. I don't like those electrons. So, but that's really the way it works. I mean, that's not a contention. That's not a subject under contention. That's just, in my opinion, an interesting fact of physics. And clearly it's perfectly consistent with the model I've created. Yes, that effect is part of what the elemental function would be in terms of the expression of a gravity that's polarized and therefore creating magnetism and electricity, which is also an important, could be a good subject for this room because there's an awful lot of people that are electric universe fans for whatever reason. And it is, I don't understand the reasons, actually. I don't understand the whole ether thing, why people like that as an explanation. The idea of the medium doing the work, that somehow the medium is influencing the stuff, and that's why the stuff doesn't fly straight, or that's why something weird happens, is because the medium says so. That's creating these fields. Oh, well, that's a good subject. We could go to a Ken Wheeler video that I haven't watched yet, that, where he claims he has taken a picture of the magnetic field. Okay. Now, I don't think you can do that. No, I don't think that's physically possible. So let's go to, what the hell is this one? Demonstration. Demonstration of what? Oh, that's that stupid thing. Ugh. All right. So I want Ken Wheeler. I think I got him on here somewhere. So yeah, there he is. All right. Well, then maybe we'll do a couple of these. My lecture in July. That ought to be a funny video. It's only 3 minutes, so it could be fun. Oh, he changed the name of the video. Oh no, here it is. Yeah, world's first flash photo of a magnetic field, I think it says. Yeah. So it's more of his, I'm the first one. I did it first. I'm the amazing person who does things, that nobody else has done. So let's see what the amazing thing is he did.
Well, I can say that I've taken the world's first flash photography of a magnetic field. 1 second, I'll show you the setup.
Yeah, this is really great, the way you do videos, where we watch something in the screen of a camera. Thank you.
Zoom in. I'll post some pictures later below.
Oh, yeah, that would be helpful.
Using a Fujifilm X-H1, the Fujifilm EFX.
So yeah, using a $10,000 camera with, $2,000 attachments, blah, 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 blah. Very exciting. And he begs for money. He's got, $1 million worth of cameras. He begs for money.
100 speed light using the 80mm macro Fuji, which, by the way, is the best macro lens in the world.
Yeah, that's right. It's only $1,200 or whatever the fuck it is.
And I have the best macro lenses in the world.
Right now. Right, he has the best macro lenses in the world, but please give me some money so I can have more great stuff that you can't afford.
I actually have a fiber optic ring light. It's for medical microscope photography. You take the magnet off of here. I had it sitting on top of my little creation here, a supercell encased in reflective foil. Let me take the magnet off. Take this off. And the fiber optic cable leads to the ring light, which this thin little slit right here is where the fiber optics terminate, and they're shooting up into.
Very exciting. I mean, you could turn it on for that just to show it, but whatever. So this is something to do with the photo of something. He took a photo of a ferrocell image, and again, he thinks that's a magnetic field.
The base of my little creation here, which actually funnels all the light, keeps it from popping through the cell, funnels it into the edge of the supercell, and it interacts.
Yes, that's exactly what you people are doing. You're shooting light in horizontally onto ferrofluid little bits of material, and the light's reflecting off the material. Yes, that's what you're doing. Yes, got that part.
With a magnetic field, I can place the magnet in back or in front, but I placed it like this, and the magnet's here of various shapes and sizes. Standing. I did a few of these shots at a half a second. Most of these shots were taken at an eighth of a second, manual F4 or F8 with the flash comp, 5 stops of flash comp, no less. And that's it. This is about as simple as it gets. I can at least say that's a first.
So what he's doing is he has the flash from the camera going into the photocell thing, brightening it for a moment, taking a picture of that brightened moment, as if that has any meaning at all, like at all we need to do that anyone would need to ever take a flash photo of something. You could just turn the light on and take a regular photo of it without doing the flash part. He's just replacing. It's like me taking turning off all the lights in here and putting on a flash and just keep hitting the flash, 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 flash. Same video, just a different source of lighting. I mean, incredibly uninteresting. So that was a real, first flash photo. So I didn't know what that meant, but he meant, flash of light. I thought it was like some sort of flashcard photo or something. So anyway, well, that is just totally uninteresting. Giant disappointment there. So let's do the lecture in July because this ought to be funny. Let's see if he says that magnetism is created by interference, that the field lines are created by interference. They're really interference lines, because that's his new spiel. I don't know where he gets that from, but it's interference of what? And that's when we'll get into words like dielectric. Yeah, let's go find out what a dielectricity is. Yeah.
Since I keep getting asked all these questions about my lecture on magnetism in July, I wanted to make it perfectly clear is that I'm not being paid at all to do this lecture, for which I've invested a lot of time.
So again, this is typical. Nobody's paid to do the things. They usually just pay for your flight and your hotel and your food and your expenses. So they pay your expenses. So you're getting a free trip to spout your crap to an audience. And he's talking like it's a terrible burden for him, to make his video in Idaho instead of on YouTube. And that's the joke of it, right? I mean, this lecture thing is something anybody can do this stuff right now. I mean, the cnps guy isn't doing this week because he's getting ready to go, in 4 days or whatever, to Virginia. So he's going to fly from Seattle to Virginia to watch a bunch of presentations that will be essentially the same presentation he's probably already heard them perform as videos in many cases, or read their papers or whatever. So it's totally redundant. And it's certainly, even if it wasn't redundant, even if somebody had something new, they could just make the video and they could just play the video. I mean, there's this whole do it in person thing. I just don't understand the value of the do it in person thing. You could even, if you had like 10 people coming to this thing and you wanted to have a conference, you could open one of these rooms and have the 10 people in the room, and you could have a video conference. I mean, there's just absolutely no need to waste thousands and thousands of dollars to all meet in a place and do this thing. Why? I just don't understand why in 2018, when you have smartphones, you're doing stupid conferences, like doing conferences the stupid way. I mean, why are you wasting the jet fuel? Because I guess just because everything has to be a little bit, you know, you want to meet up or something. So just call it a meetup or something. Don't pretend that it's going to do anything new or interesting or useful besides do what we're able to do right now, which is talk for as long as we want to about anything. There's no, the conference doesn't give you some new opportunity to speak. And in many respects, it doesn't even give you a new opportunity to be heard, because I'm certainly not going to waste money traveling to Virginia to listen to what are going to be maybe one interesting presentation and a bunch of truther crapola.
I won't have anybody filming it, but much later on in late July or August, I will give the lecture here at my house in 8 sections and upload those videos of the lecture redone in
8 sections. I don't know. It's an hour lecture, I would think. I would hope that you're not going to let you talk for more than an hour. I mean, you're just going to kill people. They're really literally going to die. If you had to listen to Ken Wheeler for more than an hour in one sitting, I mean, you're going to die. There's no way. Your brain will short circuit. Too many multisyllabic words, too much hyper crapola, and your brain will stop functioning. You'll have a brain attack.
Subdivided into 8 or 9 sections.
So I guess he's going to do his lecture subdivided into 8 or 9 sections. Every 7 minutes, he'll change the subject. So that'll be helpful. Because frankly, when he just starts going on and on and on, repeating the same shit over and over and over and over, come on.
The way it works is that they have got airplane tickets for me and a hotel to stay at for the lecture. They will be filming the lecture, for which later on I believe they'll be selling DVDs. I get no money from the lecture or the entry fees, because there are a lot of people lecturing, and of course I don't even know what the entry fee for the energy conference is, but
yeah, that's how much he doesn't give a shit. He doesn't find out who's going to the conference, who else is at the conference, how much the participants have to pay, which is about $400, I think. I mean, the viewers have to pay $400 to watch this crap for 3 days.
Whatever it is, I make no money from that, nor do I make any money from the DVD sales at all. The lecture itself,
I don't even know how they sell any of this stuff. I mean, they call themselves energy something or other. It's something in energy in their name group. So like the cnps, they're just another group of tinfoil hatters. And they're sort of worse. Well, they're definitely worse in that they're not just selling ideas. They're actually selling products. I mean, they all have some kind of wacky, actual tinfoil hat you can buy, and put on your head, and you'll be able to talk to the Venetians. They actually have bullshit they're selling, like how to build the motor I haven't been able to successfully build yet. So they have like instructions on how to build the energy saving motor that I haven't successfully built yet, at least not under $40,000. So yes, I have a $40,000 motor that's more efficient than any motor built by General Electric. But yeah, it does cost $40,000 to make. Yeah. But their world is covering it up. They're covering up my secret technology. It's not the truth that General Electric doesn't make that motor because it's impractical and it's inefficient in the sense that it costs too much to produce. Yeah. No, that's not the truth. I mean, it's just so fucking pathetic.
was completely free from my side, completely free. I get nothing for it at all.
Yes, it's the opportunity to be among the tinfoil hatters and to have your picture taken with whatever his name is, who won't show up, no doubt. What's his name? Dullard, Eric Dullard. Is it Eric? Probably Eric, because I don't like Eric's, generally speaking. And maybe you can inform him how scalar waves are real, because now Dullard says they're not. So that is an interesting conversion, you know.
So the way they actually recoup the costs of the lecture, I believe, would be the sales of DVDs, and that's perfectly fine with me.
So he said that twice now, I'm just noting. But I don't think they actually do raise enough money that way. So I think they raise money from other crazy people who think they're actually accomplishing something with their Tesla wackiness. And so there's like some rich, crazy person who believes in Tesla, and he just says, okay, I'll finance some of your bullshit. So it's just donors. So I don't have any rich donors to give me $1 million, so I can't create a whole, you know, draft science, whatever bullshit stuff.
I know there's a few people of you that said that they're going to be out there. It'd be nice to meet you. And I'll watch a couple of lectures myself. If there's any crazy people.
So he'll watch a couple of them himself. So he's so uninterested in the organization, what they're doing, that maybe I'll watch Dullard if he actually shows up. But yeah, the rest of those tinfoil hatters, I got no interest. So that's his promo. I mean, and the funny thing is like obviously the organization asked this guy, invited him because he has over 100,000 subscribers, and he's popular, and that's the only reason why he was invited, because he might generate interest in their convention of nutters.
People planning on attending, there'll be plenty of security there, so there are a few flaky people out there. I mean, like flaky. I think we all know what that is in reference to. Somebody recently made a video.
So the crazy tinfoil hatters need security from the crazy people. So it is kind of ironically funny, right? I'm not saying you don't need to, yes, I wouldn't. Interacting with, YouTube audiences in person probably isn't a good idea if you want to live a long and peaceful life.
Making fun of my lecture on magnetism, which is completely free, and comparing it in the same breath to a walkabout on photography, which is $800 a head. I'm pretty sure that $800 a head for a meet and greet is not comparable to my lecture, for which I am doing it one.
So again, he's comparing apples to the oranges, right? So the meet and greets usually have connected to them what essentially is a private tutoring. That's what you're really paying for, is to be almost essentially privately tutored by a photographer. Ken Wheeler, maybe if he offered the opportunity to query him, ask him a few pertinent questions about his whatever it is, his what's that word for fake physics? Metaphysics. Yeah, his metaphysics. That might be worth paying for, the opportunity to ask you a question.
100% free. I'm absolutely certain that $800 a head for that person's photography walkabout is in no way comparable to.
Well, again, they are charging the people who will be participating. So again, you can pretend they're not, but they are charging people to watch these lectures. So from their perspective, you're charging them. I mean, you really can't get around that. So it's the same thing in that sense. People have to pay for this participation with you, to have this privilege. And again, like has been stated, this is just going to be a bunch of cabals of his other videos just put into some new video, a new lecture that will be just as incomprehensible and nonsensical as all of his other videos.
My lecture, which is completely free, and the book of which is completely free as well.
So he's said that, what, 4 times now? 4 times in a 3-minute and 29-second video. He just keeps saying it over and over, saying this is just, I know that crap works on morons. You say, eat a hamburger 4 times, and then they'll say, I have to eat a hamburger. So that works on morons. But yeah, it doesn't work on me. It just irritates the fuck out of me.
3rd edition and the 4th edition to come out sometime this year, so not comparable.
So people pay to go, same. There's 1 or 2 or 3 only people that you're interacting with. That's different. Okay, yes, there's more people to see at this thing. But so what? In every other respect, it's the same. You got to pay to gain your interaction. So it's still paid interaction.
Lecture's all done. I get kind of tired of reciting it, and of course, I have demonstration units and lasers to ship out. I have to ship out all this equipment, lasers, bring 2 computers, ferrofluid.
So I don't know what he would need all that crap for. I mean, I think it would just ruin the lecture even more if he just wastes time doing experiments in the lecture. I think it would be, unless you can do them really quick with flashcards or something. So I wonder why he needs all of that crap.
Glass spheres, LED lighting equipment, all sorts of strange scientific stuff.
Yeah, all stuff you could fit in a backpack, no doubt, right? I mean, theoretically, the ferrofluid LED strips, laser beams. I mean, come on. Yeah, fit it all in a small suitcase.
To the lecture. And but anyway, I'm completely ready for it in July.
Yeah.
But that's the information on my lecture, because I get a lot of questions asked about the lecture on magnetism, and I think that answers every question. Goodbye.
So the interesting part will be if he's on a panel where he has to answer questions. That's going to get interesting, I think. Because frankly, somebody just ought to ask, where the hell do you have evidence of anything called dielectricity moving anywhere? Where's a dielectricity doing something? Where can I go find one of those? Can I get a dielectric shock? This is stupid. All right. So anyway, that was a little bit entertaining. Not as good as I thought it would be, but it was okay. So let's see if there's any commenters. There we go. We have some now. So we can play with those people for a little while, and then we'll move on to something else. Sexy blonde. Well, that I should block it. I should delete it, but it's probably damn true. Probably. Yeah. It seems consistent with my theory. Interference like reverb in a mic and amp sound system. So again, there's no evidence of any frequencies in a magnet. So a regular magnet, there's just no evidence of any waves or frequencies. Nothing. No evidence that those exist at all. And so I've explained where the field lines come from. They come from the fact that the ferrous material is made magnetic by the magnet. It turns it into little magnets. So the ferrofluid, the little bits are turned into little magnets. They line up like compass needles with the original magnet in exactly the opposite orientation, of course. And now they create a magnetic field when all lined up. They're a magnet, essentially. And now they repel each other because they've all been aligned the same as the opposite of the original magnet. So the original magnet is north-south. All of the subsequent magnets that are created are all going to be south-north. And they're going to repel each other. And that creates the lines. But there's no way it's any kind of, there's no lines created by forces. That doesn't happen. You're silly people. You have no mechanism. All right. Do you think perpetual magnet motor possible? That doesn't even, not a very good compiling of words. Do you think perpetual magnet motor possible? only if you can only do it if you do it in some system that has a source of energy. So I'm, in gravity, maybe. Um, there's some possibility that you could create a mechanism to harvest um, the gravity or something else, but you're harvesting energy. You're not, you can't make a machine that has perpetual energy. It's like once you blow up a nuclear bomb, it can't blow up again until you recompress all of the crap and put it all back in a small bottle. It can only blow up once. Shit, they are making just $60,000 from ticket sales alone. Bullshit. He gets no money for it. Shit, they are making just $60,000 now. Do you have any evidence they're making $60,000? I mean, how many nutters do you think are going to show up for this crazy convention? From the ticket sales alone, bullshit, he gets no money for it. Well, I would argue he doesn't. I mean, I wouldn't pay him. I mean, they can't afford to pay people realistically. I mean, maybe they could pay Dullard because Dullard brings in even more people than Ken Wheeler, I imagine. But how many people, how many people, I mean, how many people you think are going to spend the money, the transportation cost, plus the $400 fee, to go to a lecture where they still don't even have any guarantee that Ken Wheeler will even shake their hand? All right, when you repeat something is free, it means it's not. Well, you're being more cynical than I would be, but fine. I don't have any evidence he's being paid. Clearly, part of the payment is you get to Ah, it seems I'm back. I don't know. We'll have to find out. So we'll see if if this works. So I have no idea if it will or will not. No idea at all. So we'll just assume the room is working. Let's see if I load it, what it'll do. Can't really hurt anything to try it. If it will or will not. No idea. Start a new room. So we'll just assume the room is working. Let's see. Yeah, it appears to be the same chat. So, no idea. Start a new room. So we'll just assume the room is working. Okay. Yeah, it appears to be the same. Turn that off. Anyway, yeah, the computer froze. Linux. It's I'm asking it to do probably a little too much to have both cameras working. The drawing camera and the live camera. So that probably can't be something I get to do routinely. But we'll see. Maybe if I don't click on anything, maybe I have to learn to be more careful about the chat. Obviously it's a click issue. You click something and it confuses the computer and everything goes to hell. So I have to avoid whatever there's some magical click that you just don't want to do. All right, spectrum of unknown frequency. So that doesn't mean anything. Yeah, so nothing else is stated. Okay. So anyway, sorry. It's a technical problem I will have to work out eventually. And I'll try to plan on doing that. So on the subject of dielectricity. Yeah, so these are images of dielectricity. So Ken Willie did a video the other day where he showed this image and was like all, horny for it. And it's just basically the image of the two things you can measure. So the one thing you're measuring is the charge, the magnetism. So the magnetic fields are attracting each other. So that's these dotted lines. That's representing the magnetic field. So the dotted lines are the magnetic field. I don't know what this symbol is here, but it's that symbol, I guess. And this other thing is this other field. Now, the other field is just the intensity of the field in these different locations. So one is just measuring the existence of the attraction, because the magnets are opposite in a sense. So this is just like opposite magnets or opposite charges. There's like a plus charge and a minus charge, and it's the same for electricity. So these are basically just saying the wires are going into the paper, and this is the fields created around the wires. Now, one of them is just describing the fact that there is attraction, and one of them is describing how strong the attraction is at the different locations. So, and that's all this is. There's no, it's not a magical image. It's not demonstrating anything called dielectricity. It's, and none of these things are, certainly the strength of the field is a real thing, but I can draw these lines anywhere as, let's see, what's the right word I want to use? It's proportions. It's a topographical map, so you can kind of do it by any scale. So you can make it look quite different if you want to by just doing the scale different. So this has a scale where, a millimeter, and then the inverse square law kind of goes out, and the force gets, although bigger, it's weaker. Is that what I want to say? It's bigger, it's weaker. Well, it doesn't really matter. So anyway. So dielectricity, lots of different images of it, but no. Is there any consistency? So again, this is just two repelling charges. It's not anything spectacular. These are two attractive charges. There's nothing indicating what a dielectricity is here. But it is interesting. This is like a Ken Wheeler video. I'm pretty sure it would be. Let's go see. I bet it's a Ken Wheeler video. He likes toys. Unifying gravity, magnetism, electricity, and dielectricity as one thing only. So I don't know what this image is from. Let's see, there's a group of images. Yeah, Ken Wheeler. Yeah, Ken Wheeler video. So, yeah, we won't play it, but, you know, I'm tempted to, but we won't bother with that. See if we can find some other electric universe folk here somewhere. So this is a Ken Wheeler drawing here. So this is your hyperboloids and your toroids coming up the middle. Somehow, some reason you have a double donut. I don't know exactly what the reason for the double donut is, but yeah. So this is, again, so now we got dielectricity combined with ferrocells and toroids and, you know, lots of stuff stating there's some kind of movement and frequencies going on and all kinds of stuff. This dielectricity is always active somehow and doing things, but we have no physical evidence that it exists, that there's any such thing, that you can make anything called a dielectric, anything. I mean, besides a substance that's a dielectric. That is, it's an insulator that holds charge. That's a dielectric. You can charge its surface, but its interior is repulsive to the transmission of charge, the balancing of the charge. So, you know, all right, let's go to regular websites. Maybe there'll be something interesting, but I'm tending to doubt it. So we'll see a Wikipedia page. Maybe that'll say, explain to us what dielectricity is. All right, so it's all Ken Wheelers on the across the top, right? We have Van Helia. I don't know who that is. Can we see dielectricity? All right, well, let's do that one, but at least it's somebody else. This is somebody else repeating a Ken Wheeler thing, because that's a Ken Wheeler, you know, you're playing with the little optical devices. You know, that's Ken Wheeler's routine. Let's see what this one is. It's only 55 seconds, hell. All right, so we have some sort of gas coming out of something that's on fire, and there's little bits flying out. And that apparently is dielectricity. So it's a really cool looking experiment, whatever it is. It's too bad he doesn't explain it. Oh, it's water. So it was just the lights flashing on the water. So we already know that water is conductive. So this isn't a news flash at all. This is Professor Lewin's water battery. So all you're doing is creating ions. And so the water comes out of the spout and it's ionized and ends up going negative or positive, and you know, not at all any evidence of anything called dielectricity. Just evidence that ions play a really important role in charge, you know, and making things magnetic. Really important. No, that was a nothing video. All right, so here we go. Dielectricity at Wikinary. So it's some new, it's not Wikipedia. It's some other thing, Wikinary. Is Wikinary connected to Wikipedia? I'm thinking not. So this one, Wikipedia says dielectric. It doesn't say dielectricity. So let's go with this definition and see what we get. It doesn't have any epistemology. It's a noun. Quality or degree of being dielectric. There, isn't that informative? Yeah. So dielectricity is the quality of being dielectric, which doesn't make any sense. I mean, that's like saying magnetism is the quality of being magnetic. I mean, it just doesn't say anything at all. That's just a nothing statement. I want to go back this way. Thank you. So totally unhelpful. So let's see what dielectricity. Let's see. Nikola Tesla. Okay, well, you're not going to get anywhere with that crap, but let's see what it says. All right, Nikola Tesla's lectures, patents, and articles. He doesn't have any lectures, so that's sort of a joke. Sound and healing. Well, isn't that cute? They have little pseudoscience videos on their page. Science providing climate something or other. I wonder what that crap is. Science providing climate change is not man-made. So more, fact deniers, truthers, and certainly associated with Nikola Tesla, which makes sense. All right, lectures, patents, and articles. So let's see if we can find something called a lecture. No, nothing there. So now it's Charles Proteus Steinmetz theory and calculations of alternating current phenomenon. Yes, so let's go back to 16 to find the truth. Yeah. And now we have Eric Dullard, Introduction to Dielectric and Magnetic Discharges in Electrical Windings. So again, there's a dielectric discharge. Yes, the dielectric can discharge. That is, an insulator can discharge its charge, but it's not called dielectricity. It's the same electricity as electricity. It's not a different form of electricity. It's just so stupid. So this is just a collection of nutters. Very interesting. Oliver Heaviside. It's all the Ken Wheeler guys. These are all his. This is again where we're supposed to get all the truth from. So let's click on the Nikola Tesla thing and see where we go. Let's see. This file is too large to preview. Well, I don't even know what that makes. That doesn't really make any sense, but fuck it. So maybe that's just the image. Yeah. Here. So here we have, it's a PDF file. Now, that's probably not going to be terribly interesting. Oh, it's too big, so I have to download the whole thing. Yeah, well, fuck that. Probably have to pay to download it. All right, screw that reference. This reference sucks. So Dielectricity Archives, Eric P. Dullard. I don't think he's made a recent video, so I don't know. He's had some health problem. I don't know exactly what he's got, but I don't know if he's like I said, he's supposed to go to the tinfoil hat convention, but I don't think he'll make it because he always says he's going, but he never goes. All right, so no real good comments here at all. So we haven't moved anything. Can gamma move matter? Anything, any force can move matter. So a single photon will move the matter it hits. So, of course, anything, beta, gamma, alpha, any radiation, any moving thing that hits another thing is going to move it. Now, how much it can move it is just a fancy prison. Prison. Just a fancy prison. I don't know what that means. You gotta type better, or I just have to say fuck off because they're 4-letter sentences and you can't type 4-letter sentences correctly. Come on. Yeah, I mean, come on. For a word, I'm sorry. Yeah, gotta do better than that. In my opinion, you have to do better than that. Yeah. So I'll just repeat again. If somebody wishes to participate live in an interaction talking about physics, post a request in the chat and I will provide you the link to the room and you can get in here and say something interesting or not. So let's see. I guess we'll just go to the Wikipedia page. Dielectric. A dielectric, okay, so let's see how close my definition is an electrical insulator. Well, there, I got that part right. It can be polarized. That means its surface can be charged by an applied electric field. That is, by applying charge. It can collect charge. You can put charge on it. You can have charge on your finger, touch a piece of glass, and you can place the charge on the glass and take it off of your finger. Yeah, you can do that. That's what dielectrics can do. When a dielectric is placed in an electric field, electric charges do not flow through the material. So it's pretty much exactly what I said. They don't go through the glass. They just sit on the surface, as they do in an electrical conductor, but only slightly shift from their average equilibrium positions, causing dielectric polarization. Well, charge, that's what it's doing. You're placing charge on the surface. There's no, it's just a charge on the surface. Because of dielectric polarization, positive charges are displaced in the direction of the field. Positive charges are displaced in the direction of the field, and negative charges shift to the opposite direction. So obviously just saying that one surface will be positively charged and the alternative surface will be negatively charged. So if I put positive charge on the outside of this bottle, the inside of the bottle will go negative. All right, this causes an internal electric field that reduces the overall field within the dielectric itself, well, which means there's no field inside, yes. If a dielectric is composed of weakly bonded molecules, those molecules not only become polarized, but also reorient so that their symmetry axes align to the field, which means they essentially sort of start becoming magnetic. The study of dielectric properties concerns storage and dissipation of electric and magnetic energy in materials. Yes, that's used to store charge. Yeah, that's what they do. Capacitors. Dielectrics are important for explaining, I don't know if they explain anything, various phenomena in electric, optics, solid state physics, and cell biophysics. So again, they're just basically talking about insulators that hold charge. So chargeable insulators. Yeah, it's just, that's it. There's nothing else to say here. And they can have, different substances can have different abilities to resist any transmission through them. They're stronger or weaker insulators. But this dielectric, it really isn't anything but just basically saying insulators used as charge carriers. That's dielectric. So anyway, so I was fundamentally correct in my explanation, at least fundamentally consistent with Wikipedia, so they can still be full of shit, of course, but the basic argument is an argument. Now, whether there's anything called dielectricity, let's see if there's anything called dielectricity in here. References, application, blah, 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 blah. It doesn't look like it. It's electric. It's just there's no dielectricity. There's no such word in real physics as dielectricity. It's something Dullard made up, I think, or Steinmetz, I think, made up. But it doesn't. It's not real stuff. It's just a way of explaining the fact that you had electricity in these different locations, and so because the electricity was in a location that doesn't seem right, like on the surface of an insulator, That doesn't seem like a place where electricity should be. They called it something different, but it's the same electricity. It's the same charge. It's just on a place you don't usually find electricity. It's not a place you would expect electricity to be able to hang out. And so they called it something else out of a kind of ignorance. But it's exactly the same charge. It's just on a different kind of substance. Yeah. All right. So still nothing from the audience. So very little participation and such, which is, discouraging, but I will have to endeavor to persevere. So I don't know if we need to kick the dielectricity any further. So let's see if there's any new subscriptions. Oh, Tyler's back out of the nut house again. So he's doing a live stream right now too. That's pretty funny. So he's live streaming my live stream. So I probably should try to open that just for the shits and giggles, or whatever they say. Newsflash at all. I've never said that before, actually. Shits and giggles. I don't think I've ever said that before in my life. That's the first time I've said it. It's kind of frightening when that happens, when the culture finally does invade your brain with some nonsense term, and then one day you actually say the nonsense, and you're like, shit, they owned me, they got me, they made me say that stupid thing. Oh, but it's kind of like deja vu when it happens. You have this feeling like, whoa, my brain knows I just farted. I mean, my brain just did something it knows it shouldn't do. This is Professor Lewin's water battery. Oh, it's an old episode. He's playing one of my old live streams. It's not this live stream. So that's even funnier. Oh, okay. So it's not as funny as, well, it's funnier, but it's not as funny because it's obviously an older video he's playing. All right, so he keeps changing the name of his channel. So it's Get Rich or Die Fasting. Just so he's into this whole drink your diet or breathe air and eat air for a week or something. I mean, I people can have all kinds of gimmicks to get through their life, and that's okay with me. But I mean, I don't think it's the secret to anything really cool. So now art quizzes use the web. So apparently this Professor Lewin has a thing for, in my opinion, shitty classical artists, ones that weren't even that good. And is going to blend that into his physics, and it happens. We're all stuck with that. I mean, some of my peripheral activities get blended into this, but it doesn't necessarily happen because I want it to. So I don't try to mix subjects at all. But whatever. It is sort of telling, though, because you can sort of see his fascination with art is kind of chaos art, art that isn't very well, that isn't simple and elemental. And so part of the argument would be is that, that's sort of revealed in his whole way of living, that, it's not very direct. And, frankly, it's a little clownish. I mean, the sunglasses and the hair and he always wears, kids' clothes, Yeah. So, I mean, it is, I have exactly the opposite internal personality. I mean, if I had suits, I'd probably wear one, probably. Well, if I didn't have to wash them or take care of them or do, any of that shit, then I would wear them. So if I was, if I could just throw them out after I used it for the day or something, if that was not insane, then I'd do that. But anyway, all right. So we have nothing in the subscription box. Doesn't provide us with anything of useless except 600 Tyler videos. Some of them 6 seconds long. There's a 2-second one. A 3-second one. Yeah, great. Whatever. Whatever. I mean, psychiatric issues are a real thing.
No area of physics causes.
Oh yeah, this video. I have to do this video someday. Tangled up in quantum mechanics. It's just such a Lawrence Krauss is such a butthead. Anyway, insufferable butthead. So, I don't know if we would need to bother with any of these others. Portrait, easy way of getting into the business. Crimea River. So this video on dielectricity doesn't explain dielectricity. I already played that and just didn't. It's all his just jargon. There's no explanation of where I can do an experiment to demonstrate dielectricity. So it's not very useful. All right, so we did an hour and a half. I suppose that's good enough effort. The usual thing is 2 hours, but there's nobody participating really, and so the whole point of the all I can do is make the conversation available. I can't force you people to drink, so it's the way it is. Did my part. Yeah, pretty much. So if you have something to say it now, or else I'm going. And such. No, I guess not. All right, so we'll call it basically a huge failure, but that's all we get is failures. Do bullshit jobs get paid the most? Well, obviously, not jobs gets paid the most. Okay, I mean, just inheriting a big pile of money pays the most. Buy stuff and watch it go up in value and say, haha, I made income and I didn't pay the people who go to work every day pay more taxes than I do because I didn't work to get my money. So it's just totally stupid. So anyway, thanks, man. So saying thank you for basically not being very I mean, I'm just sympathetic. That's all I can be. But yes, I can't do anything more than just be sympathetic for the struggle that is finding your place on this planet. Ken Ferrocell. Well, that doesn't mean anything. Fancy Prim. That doesn't mean anything either. So obviously, I gave you a last chance, and nobody could come to the table with any room-saving comment. Not even close. So anyway, until the next time, and such, and so forth, and whatnot. And I guess this is the one I want. Nope, that's not the one I want. I want this one, I guess. That's the one I want. So anyway, sorry about the interruption in the middle. You'll just have to live with that, I suppose. And till the next time, and such. It's great that I was able to resave the room, so at least I know it can be done. So till the next time, such.